So let's continue from this topic. As you know, we have already started vector space and we proceeded till vector subspace. Now let us start with this theorem to continue further. The statement of the theorem is the intersection of two subspaces of a vector space V over a field F is a subspace of B. Exactly same theorem you already got in group theory, that intersection of two subgroup of a group is a subgroup. Similarly over here, the intersection of two subspaces of vector space V over field F is a subspace of B. Let's come to the proof. First of all, let us choose two subspaces W1 and W2 of a vector space V. Obviously, there is a field F, because without a field, vector space is nothing. So, let us choose two subspaces W1 and W2 of a vector space V. First of all, we have to show that their intersection is non-empty, because if there is nothing in their intersection, then there is no question of proving this. So clearly their intersection is non-empty. Why? Because null vector, at least the null vector is common to both. At least the null vector is common to both. Now in case 1 we assume only null vector is there in the intersection. Only null vector. Null vector is there, but in case 1 I assume only null vector is there in the intersection. Then null vector is a subspace of any vector space, so it is a subspace. Case 2 I assume intersection is not exactly equal to null vector. Null vector is there, but it is not equal to null vector. There is something more to it. That means apart from null vector, there is something more to it. Now let us choose two non-null vectors alpha 1 and alpha 2 from the intersection. Alpha 1 belongs to this intersection means alpha 1 belongs to both W1 and W2. Alpha 2 belongs to this intersection means alpha 2 belongs to both W1 and W2. That means alpha 1, alpha 2 both belongs to W1. Alpha 1, alpha 2 both belongs to W2. Since W1 is a subspace of V, their sum belongs to W1 and their scalar multiplication also belongs to W1, because this is the condition for a subspace. We already did necessary and sufficient condition. Alpha 1 plus alpha 2 and C alpha 1 belongs to W1, where C is a scalar, because this is a subspace. Similarly, since W2 is a subspace, same thing happens in case of W2 also. Alpha 1 plus alpha 2 belongs to W2 and C alpha 1 belongs to